Hello guys, welcome back to day 18, 19, something. Today we will be doing three integer sum. I just realized from the last problem, uh, like what two pointers are, like from the beginning of the list and one in the end of the list, and the technique. I briefly watched the solution and it made sense. But yeah, today we'll be doing three integer sum. Let's get right into it. Give it an integer array of numbers. Return all the triplets, so a list of three values where when they equal to each other, it's equal to 0. Where if these are equal to 0, and these IJK are all the same, what? Give an integer where all return all triplets, where equal to 0. Indices IJK are all distinct. Okay. Interesting. The output should not contain duplicate triplets. You may return the output. Okay. So let's say 4 minus 4. Right? Minus 4 is less than 0, so we're going to look for something that's positive. Here we find positive value. We're getting closer. If we go over here, get another value. That gives you 0. Over here we got minus, okay, minus 1. Increase it over here. 0. Still negative. Going closer. Hmm. So they want us to return a list of possible things that can give you value, but technically, oh, I see what they did there. Thing is, minus 4 plus 1 plus 2, yeah, it doesn't count. Okay, so okay, makes sense. So we're gonna have a pointer here, a pointer there. If I need to use two pointers, what would I do? Okay, well, I could sort it. So that would be, let's say I sort it, right? I do print the sorted values of the numbers. That would allow me to figure out something. But even then, it's I can do -1, and 2, and -1, -1. So what I can notice is that nothing can equal to -4 because all of the positives add up to 3, which is also 4. So then by default, I can move the pointer to the left. Then I could combine -1, 1, 0, -1, -1. Could do a hash map for that too. There is another example, I think. This one, there isn't any, so it's going to turn nothing. And we can have a list of zeros. Okay. This is a little tricky. Um, so give it, just gonna read this. Given the arrayed integers numbers, return all the triplets, num1, 2, 3, I, J, K, all in distinct. Output should not contain duplicate triplets. You may return the output and the triplets in any order. Perfect. -1, -1, 2. Okay. So it's gonna be a list. Integers. All right. So first things first, right? That we need to know is there potentially will be duplicate numbers, but they don't also use duplicate indices. That makes sense. So I feel like if we want to keep a value unique, we should pop it. Feel like it's and I want us to return all the lists of potential things you could use. So I could sort it and do the two-pointer thing. My question is, it's not like we have two values, we have a list of values, right? So what I could do is have the left and the right pointer equal to 0 and pronouns minus 1. And we need to make sure our conditions are true. So we want to have here and here, add them up. They're negative, so we want to balance it out. So we could just do -1, -4. Add them together, it's -5. Plus this one doesn't work. So we put these indices maybe in a hash map to show that we've already done it before. Maybe. And then we could do -1. But my logic is if the positive values don't add up to the max. Like this negative value and all the positives, or two positives, let's just say, it won't be equal to -4. I could brute force it. I don't think there's anything holding back. So -1, -4, 0 doesn't work. -1, -1. I want to cancel out the 0 though. Like if I see, let's say for example, in this scenario, right? We have a list, and if we go and add up the values, it won't give us anything. So I could do a pointer here, a pointer here. and then we add the pointer to the right. Doesn't work. Oh, I could still do that actually. I could do it like that if I wanted to. -1, -4, -5, and then that's whatever. Okay, if I sort it, I could do -4, -2. Oh, so we're still negative. Okay, so we're gonna move the point to the right, -1. Here, 3, still negative. We don't count it. We shift it to this to the left. We know it's not possible. We do -1, 2. We're still positive. We move this to the right, -1. So we got -1, -1, 2. It's correct. We put that into a list. We put that to a list. Then we do -1. Uh, we append it only if it exists, right? So we found the first combination. Now we have -1, right? And we have 1. Okay. So it's 0. So we're still greater than anything. So we can move it to the left. Actually, if 2 is equal to 0, two numbers are equal. If we add up two numbers and they're equal to 0, if we can find another value that's 0, we put that value in. Now, how do I make sure that these are unique? Okay, so let me write this down. So we have our left pointer and right pointer, and we sort it, right? So let's say we do sorted nums. ThreeSum nice. Okay. So okay, there's a slight issue. Really, while so can I say while L isn't equal, and we just keep going to like the center or something. We should like automatically adjust the certain endpoint after we find a certain. Like for example over here, oh, so start with the left position and we add up the right position. If it's still less than, do this, right? If it's still negative, if the value is still negative, which is -2, adjust the right position to the left. Boom. Add these together. If these numbers are still negative, we set the start value for left to -1. Okay. But then we start comparing it with everything. This, this, this is still not jump. We add this up. Still add this up. Still add this up. Still boom. If this still positive, shift this down. This still positive, shift this down. Okay, makes sense. I'll just take this out. So, boom. Now we have a while loop, right? We are going to check the left position, right? So nums at position L, right? I could set it to equals to x just in case, because I don't really trust these terms. Plus whatever. So boom. Nums at L, right? So we're gonna do nums at L. So we can say if nums at the starting position plus the nums at the furthest right position is less than 0. So it's negative. Then we're gonna adjust. Wait. So let's say we have this and this is negative. We're gonna this and this is negative. We're gonna adjust the one to the right. So we're gonna try nums L to the right. So if it's still negative, we're gonna try if nums L plus nums I plus nums right minus 1 is equal is not equal to 0. So actually, first things first, right? We have to start with adjust the L positions, right? So if this is the case, so if this plus this plus this is still negative, still less than 0, then we're going to do L plus equals 1, right? And yeah. So that's if this, and this is less than 0. Let's say this, and this is not equal to 0 as well. Let's say it's greater, right? Oh, try to do that. Elif nums L plus nums R plus nums R minus 1 is greater than 0, right? And then do R minus equals 1, right? That makes sense. So if this, and this is greater than 0, then we know that we have to adjust this value. To the right, so to the right to the left. And if it's neither, then we know it's equal to 0. So we're gonna do a I'm probably gonna do that now. So we do answers is gonna be equal to a list, and we're gonna do ans.append. It should be a hash map, because let's say we have, I could convert to a hash map, then convert it again, or I can make it a set right now, add that set of values, and if later on there is duplicates, I can convert it. How do I convert it? Convert set to a list. I just do a list around it. Yeah, I could do that. So I'm just gonna do is equal to set, and we're going to do ans.add list of nums L nums R R minus. Is this efficient? Hell no. Because if we're checking over here, if this is greater than 0, so it's greater than 0, right? If it is greater than 0, here's what we are going to do, right? We are going to adjust certain things depending on what we add. So let's say this is greater than 0. We want to adjust to this value. So if nums L plus nums right plus R or L plus 1, right? So we'll adjust to one on the left, right? So boom. So if those values is less than 0, right? So if we do this, this, and this is still negative, right? If this, and this is still negative, then we know this is not possible, right? Wait, this and this, right? Oh, it's possible. This, this. Oh, let's say that is positive, or that is negative, right? If this, and this is negative, then we want to solve, then we want to we can do left position. Is greater than 0. So let's say this, and this is positive. Then we want to offset the problem. Else, if it is, we're just going to add those numbers. L R this one. Yeah. Right? And basically, I'm going to keep doing that. Right? And if both of them are 0, right? So else, if they are equal 0, we're gonna see if there's a 0 within this list. If it is, if 0 in nums, then we want to say x is equal to the index of 0. So we're gonna do x is equal to nums dot index, right? But the thing is, there might be multiple zeros. So theoretically, yeah. Find that. If 0 is in numbers, it's false. That index, right? If it isn't, get the index, we're just going to do and dot add, and add the values of its list. Left, right, x, else. Let me try this. None. Interesting, interesting. Probably because the set thing I did. Oh yeah, I didn't return anything. Return list value of interesting. So left and right aren't equal to each other. Left and right are not equal to each other. This is true. Okay. Um, I'm gonna test something out. Just yeah. Still disorganized. I see. So I gotta make it like nums is equal to sorted nums. Make this the list value. So they're saying they have a problem. Unhashable type list. Why can't I hash a list? It's very interesting. If that's the case, then I don't need to stress too much. So, interesting. I am not gonna question that. I'm just gonna do a simple adjustment. Very simple adjustment. Very, very interesting. So I'm going to do and brackets and that's perfect. Actually perfect. Okay. So we kept going till they weren't equal. It's very, very interesting. I'm gonna do one last thing just to test it. Nums is being equal to sorted nums. Right. So while these aren't equal, I'm gonna check if leftmost, rightmost. most. It's like it is. This, this, or this. Very cool. It's greater than 0. So just one less than 0, greater than 0. If it's not the case, oh, I have the idea. I don't know what's. I probably don't even need that many if else statements, man. Okay, if it's greater than 0, I'm gonna. So we could try L, R, and. Okay, I could try this, this, and this. It's not equal to 0. We could try this, this, this. If it's not equal to 0, we're going to do this. Let's try both of them. Then let's offset either. Alright. I don't know. I tried. I really tried. But don't. Probably overcomplicated it. And a distinct, I gotta implement a hash. So
Okay, let's solve LeetCode 15, ThreeSum. The sequel is equal to nums of I minus 1. That means it's the same value as before. That means we want to continue. We don't want to reuse the same value twice, so we're going to continue to the next iteration of the loop. Next, we're going to use our two-pointer solution for the remaining portion of the array to basically solve TwoSum. So we'll have left and right pointers. Left will initially be I plus 1. Right will be the end of the list, length minus 1. Left and right can't be equal, so we're going to say left is less than right. Now we're going to actually compute the sums. So we'll say our ThreeSum is A plus nums of left plus nums of right. So if the sum is too great, remember, if it's greater than 0, which is what we're looking for, then we need to decrease it, in which case we would say our right pointer needs to be decremented. On the other hand, if it's too small, we need to make the sum bigger. If only I could type today. If it's too small, we need to make it bigger, so shift our left pointer to the right. The last case is if this is equal to 0, so of course we have to add it to our result. So to our result, we're going to append all three numbers. So the numbers are a, nums of left, and nums of right. Now, of course, we got to update our pointers, but how do we update it? There's a lot of ways you can do it, but I'm going to show you the way that you can do it with writing the minimal amount of code. So let me just write a comment to show you a little bit. What if we had the ThreeSum basically for these left and right, and we were at -2, -2, so -2, 0, 0, 2. Unless I've made another stupid bug, we should be able to just return our result and but remember they really want you. So this is all be able to just return our result and pass the problem with the most optimized solution. Okay, I'm praying that this works on the first try. Let's see. We passed the test case, the first test case. They really want you to buy LeetCode Premium. This is taking... Okay, so it did pass. Pointer by equal to nums of left minus 1. That means it's the same value, so we have to keep shifting our pointer. But remember, we don't want our left pointer to ever pass the right pointer, so we're going to add that to the condition. So this is all we needed to do. Now I believe, unless I've made another stupid bug, we should be able to just return our result and pass the problem with the most optimized solution. Okay, I'm praying that this works on the first. Our right pointer was here, and that our sum is going to evaluate as too big, so our right pointer is going to be shifted again. Notice how each value